So with that, I'd like to invite one more person up on stage to talk about how understanding attackers can lead to better security. And so with that, Ryan Olson, our VP of Unit 42.
Thank you, Lee. Thank you. Good morning, everybody. I'm aware that I am the only thing that stands between you and lunch. Stick with me. This will be entirely worth it. So if you haven't heard of Unit 42 yet, we're the team inside of Palo Alto Networks who's focused on adversaries, understanding them, understanding how they work, and how to prevent them from being successful. So there's two things I want to talk about today. One is the group that Renee alluded to earlier, Oil Rig. And this is a slide that sort of describes how they operate. We've got some other names for them. They use custom tools. They use DNS tunneling to tunnel information out of networks. They have a rapid development cycle, and this is the kind of information we like to supply. We want to give you this high-level overview of how an adversary works, as well as detailed reporting on how the adversary operates, all the indicators you can use to defend against them. But one of the challenges with conveying this kind of information is that when we release a report like this, some poor guy reads it, and his boss tells him, hey, tell me how you're defending against this group. How are we defending against Oil Rig? And his answer is probably going to be, well, we've got all these products, and we blocked all the indicators that are in the report. But that's not a very good answer. A good answer would be, we understand how Oil Rig operates. We understand how they work, and we know what kind of visibility and controls we have in place to prevent them from being successful. So Oil Rig's one thing I'm going to talk about. The second thing I'm going to talk about is Tecmo Bowl. Tecmo Bowl, released in 1987 for the Nintendo Entertainment System, very sophisticated simulation of American football. And the reason I bring up Tecmo Bowl is if you ever played this game, what you might know is you had to select which play you were going to run by selecting one of these from the lines, either running or passing. And if you selected the right play, because you knew what the player 2 sitting next to you was going to play, you would always win. You would be able to defeat them because you had a better understanding of which play they were going to operate. And the reason this is relevant for us is because I want to talk today about adversary playbooks. Trying to understand what does the playbook that our adversaries are running against us look like so that we can build better defenses. We've been talking about this concept for a couple of years now. And we were thinking about how could we structure information in a way that would let us understand what an adversary's playbook looks like and what would we need to do that. And there's a few components that we pulled together. One is this thing we call the attack lifecycle. You might have heard as the kill chain. This is a phased approach of looking at what does an adversary have to do to be successful in accomplishing their ultimate goal. Typically, they broke down in these phases, and these are each opportunities where you can interdict an attacker. The second thing is the attack framework that MITRE released. I'll dive into this in just a couple seconds. And the third thing is STIX. STIX is an information expression protocol. So first on attack. The way that MITRE, it's a company based in the United States who releases lots of free information. When they released attack, they sort of constructed it as deconstructing the attack lifecycle. So take the attack lifecycle, which is very high level, and then break down something like the delivery phase into specific techniques that you can understand. What are the actual techniques, like a drive-by compromise or a spear phishing email that contains with an attachment that an adversary might use? Just understanding its delivery phase is helpful in saying where do I need to be in that process, but attack breaks this down at a much more specific level. On the attack website, there's about 183 different techniques that all have standard names, definitions, links to more information about how this technique has actually been used out in the wild and how different adversaries have employed it. So we have the attack lifecycle. More specifically, we go down to techniques that are described in an attack, and then we move on to STIX. STIX stands for Structured Threat Information Expression. This was originally an XML framework for describing what we know about how an attack occurred. And STIX 2.0 is the version that we've adopted for the adversary playbooks. This is actually a JSON format where we have objects, those little nodes up there that identify indicators and malware and adversaries, and links. It's basically just a giant graph that you can build up in JSON. So the combination of these three things, the attack lifecycle, attack, and STIX 2.0, where they all come together, is this thing that we call an adversary playbook, a method for organizing all the TTPs that a group is using in their attacks in a machine-readable format that you can hand to something that a tool, a machine, can actually make use of. That's the adversary playbook. Let's jump into Oil Rig for a little bit. Oil Rig is a really important threat group. And I'm just going to throw up really quickly a timeline of attacks that we've seen, in one slide, Anyone wonder how we actually name threat groups? It's actually not nearly as complicated as you might think. This is actually the Slack conversation that the two researchers on my team who were investigating this group had as they were discussing it. They found the string, nafty, it's the Persian word for oil that was included in one of the binaries they were investigating. And they had this conversation, hey, this string is in here. Oil rig's a really cool name, let's go with that. Years later, we've written tons of reports about this, and we're talking about it here. We have logos and everything. This is oftentimes how it works. Now here is a timeline of oil rig attacks. You can see starting in May 2016, up through the present, many attacks against organizations in the Middle East, in the United States, government, finance, people working in all sorts of industries have been targeted. And this is a group that moves really fast. They change their tools a lot, they change their tactics a lot, and that's why it's a group that we think is useful to try and understand their playbook. Today I'm going to talk about a few different things that we've seen in attacks over the last couple years. We're going to start in May of 2016. This is the earliest attacks that we were seeing from oil rig. And this giant thing on the screen right here, a bunch of random looking letters, is a SHA-256 hash. This is the hash that we use for uniquely identifying a single sample. This is where we started. We had a single hash that we were going to go and investigate. Here's a screenshot from autofocus. If you haven't seen autofocus before, this is the wildfire report for that specific hash. You can see that it's highlighted up here. That's the hash that we're looking at. And down here in the file activity section, we're actually looking at unique things that this sample did. What did it do when it was running inside a Windows virtual machine? And in that middle sort of red bubble column there, you can see that there were 8 other files that did the exact same thing as that original sample we were looking at. Only 8. As Lee said, we've analyzed billions of files. There's only 8 of them that did this. So we took all those things together and we said, aha, we can expand from one sample that was interesting to 8 or 9 samples. We have a bigger group of data to pull together. And once we pulled all of these together, we gave it a name. We looked at this one and we said, this is a particular toolkit that is being used by a group, and we called it ClaySlide. ClaySlide is interesting. It lives in the delivery phase. That's what it's used. It's to get some sort of malware into the network. It's typically distributed as an Excel file, delivered over spear phishing. So this is an email you're going to get with an Excel file that's actually attached. And the Trojan that ClaySlide typically delivers is called Helminth. Helminth, for a little more information on it, is both delivered as an executable file or sometimes as a script file. So they've got 2 different tools that they built, really with the same functionality, but in different formats. It's a fully featured backdoor, which doesn't require much for a backdoor. If you give me a command line interface and the ability to upload and download files, I'll call that fully featured, and Helminth gives you both of those. And it's capable of using DNS tunneling for command and control. I'll show you an example of what this DNS tunneling actually looks like. Here are 6 DNS requests that were executed by Helminth. These are things that you would actually see in network traffic. And if you were to even look at your DNS logs, which unfortunately a lot of people are not even investigating, you might notice that these look a little out of place. You might notice there's a little bit of a pattern in them. You can actually see a sequence number that's running here toward the beginning of it after the 00L0. 1, you have 0, 1, 2, 3, 4, 5. And then later, you have this big chunk of what turns out to be just hexadecimal data, all resolving under kernel.ws. If you line all of these up in the sequence order and you decode them, what you'll actually see is data being exfiltrated out of the network. This is information that Helminth was acquiring from a host that it had infected and was sending it secretly out over the DNS channel, something that most people might not even be monitoring for, won't necessarily pick up. We're going to jump ahead to September of 2017 and look at another attack that was launched by this group. Here, we're actually in a different phase of the attack lifecycle. So earlier, we were talking about delivery. But over in actions on objectives, at the end of the attack lifecycle, lots of interesting stuff happens. In this case, oil rig was using a tool that they called RGDoor. RGDoor is a backdoor for a web server. Oftentimes, we see backdoors for web servers deployed as what we call a web shell, where they put a PHP file or an ASP file in a certain directory. And if they know where it is, the attacker can go and access it. RGDoor is more stealthy and much more sophisticated. It's actually installed as a backdoor into IIS as an IIS module. And we've discovered it on multiple legitimate web servers, primarily deployed in the Middle East, just by doing some simple scanning. And I'll show you how this works. Rather than the attacker having to find a specific PHP page, they are accessing just this IIS server through the module. If you were to look at the IIS manager interface, you would see this is actually the line for RGDoor installed on this computer. We have talked to organizations who are infected with this Trojan. directly and said, hey, you're infected with this, you need to remove this module. And still looking at that interface, they look at it and go, I'm not sure. I don't think I want to remove that. That might break my web server, because it's legitimately named and it looks like it belongs in that place. Since you don't have a specific URL to go to we'll jump ahead just a little bit. RGDoor is a really interesting backdoor, and the way that you access it is just by passing a specific cookie to a web server. You go to a URL, you pass a cookie in, and that cookie is actually decoded as a command that you then get to go and execute. If we wrap everything that I'm talking about for Oil Rig together, and we try to bring it back to the idea of a playbook, I asked a couple analysts on my team late last year, hey, go see if you can build one of these things. Look at all the campaigns that Oil Rig has executed. Look at the techniques that they're deploying. Look at indicators that you can find for these techniques, and see if you can build a Stix playbook. And they went out and did it. And this is the result. It's really ugly. And that's what I said when I saw it. I said, JSON is never meant to be looked at by a human being. That's a machine-readable format. We need to do something slightly different so that people can understand this. So we went out and built this thing that we call the Playbook Viewer. This is what it looks like. We've got 9 playbooks that we've deployed in it right now. Over on the left side, you have published playbooks. These are things that we've made public. They're all out on GitHub. Anyone can access them. They're open source. Up at the top, you have a description of how that adversary Oil Rig works, or whichever one that you've selected down there. You have a list of campaigns over on the right side, which actually shows you different campaigns and the timeline from when we saw them. And then at the bottom, all the techniques that we saw across the attack lifecycle in the attack framework, so that you can see which one were used in this specific campaign. If you click into these, you can actually go and see indicators, things that you could use to try and find that technique used by that group in your network at that very moment. Like I said, anyone can get to it. This is the URL if you want to go access it. But if you Google for Unit 42 Playbook Viewer, that's probably your fastest way there, rather than trying to memorize that long URL. So at this point, most people are wondering, how should I actually use this information you have given me? What would I want to do with an adversary playbook? So one of the 3 use cases is simulations and ranges. If you have an opportunity to do the cyber range here, if you've got tickets for it, I heard it's sold out already, you can actually see how we might be able to use this information. We have created cyber ranges specifically for Oil Rig based off this playbook data. We're working on more of them now, and we hope more people in the industry start using this to say, how can I emulate an adversary and see what they would look like inside of my network? The most obvious one is defense evaluations. Look at your tools, look at the attack techniques that are being used by an adversary so that you can say, are we defending well against Oil Rig? What tools should we go and deploy next to make sure we have the right visibility and the right controls to stop an attacker from being successful? And the last thing is we're looking at all the ways that we can build this kind of intelligence into the application framework. We already have a lot of this information inside of autofocus, and there's lots of creative people at Palo Alto Networks thinking about how we can put this into every part of the framework as possible. And with that, I'm going to hand it back to Lee. Thank you, everybody.